So in this video, we're going to look at gravitational potential energy, kinetic energy, and how they can be transferred between each other. We're going to start with GPE. Now, gravitational potential energy is often abbreviated as GPE because physicists are lazy and don't like to write out the entire thing. The equation for GPE looks something like this. GPE, which is one phrase, it's one thing, equals mg H. Now the M stands for mass, and that is in kilograms. So if you're given a mass not in kilograms, you need to convert it into kilograms to make this equation work. G, which is the gravitational field strength of the planet that you're on. Now on Earth, where most of your problems will be, that is 10 meters per second squared, or 10 newtons per kilogram. Now at GCSE, we generally use the number 10. As you get up through physics, you'll start to use either 9.8 or 9.81, and this is also the acceleration due to gravity. It's the same value. And then there's H, which stands for height, and that is measured in meters. So if you're given a height in a different value, so maybe kilometers or centimeters, you need to convert it. Now sometimes you'll actually see this equation written a little bit differently. You'll see it written like this: delta GPE, that's not a P, equals mg delta H. And the delta is a Greek letter, stands for change in. So all this means is that the change in gravitational potential energy is equal to mass times gravitational field strength times the change in height. There's one more little thing to think about here. Mg, you might recognise that phrase because this is equal to weight. So the equation for weight equals mg. So you sometimes might see this written as GPE equals weight times height, because weight is mg, so it's got that already packed in it. And in that case, your weight needs to be in newtons and your height still needs to be in meters. To give you your answer, the unit of GPE is the joule. So both of these have got the joule J as the unit. That is the standard unit of energy. So we're going to have a go at a couple of questions that use this equation. Some of them are slightly easier, some of them are a little bit harder and need some rearranging. So the first one here, a 2 kilogram box is lifted 3 meters in the air. What is its GPE? So the first thing I'm going to do is write the equation. GPE equals mgh. Now, if I underline what I've got 2 kilograms, that's the mass. I've got 3 meters, that's the height. And G, I have to just know that it is 10, or 9.8, or 9.81, but a GCSE standard is 10. So I'm not told that. I need to remember it for myself. So 2 times 3 times 10, that comes out as 60. Then I write the unit, which is joules, and I just write it as a J. Be careful to use a capital J, not a small j. I often see students writing a small j for joules, and it's better to write this than it is to write joules. The unit symbol is better than writing the word. The next question, the same box, so if it's the same box, I know it's got the same mass, so it's 2 kilograms again, has been moved so it has 90 joules of GPE. What height is it at now? So now if I write my equation down, GPE equals mgh. I'm not looking for this anymore, I'm looking for the height. So I'm going to rearrange this first. I'm going to rearrange it while it's still in the letter format and make sure that h is on its own. Now to do that, m and g need to go to the other side of the equation, and as they're multiplying over here, they're going to divide over here. So we're going to write GPE divided by mg equals h. Now I can put my numbers in. So height equals GPE, which is 90, divided by the mass, which is 2 from the first part of the question, times g, which is always 10, and that will come out as 4.5 meters. And that makes sense. It's gone higher now. It's gone from 3 meters to 4.5 meters, so it now has more GPE. The higher up something is in the air, the more GPE it will have, because GPE is all about where you are relative to the Earth's surface. Finally, a little bit harder. A dog climbs up a hill to a height of 0.2 kilometers. If it has 30,000 joules of GPE, what is the dog's mass? So once again, I'll write down the equation, GPE equals mgh, and I'll think about what I've been given. I've been given 30,000 joules, so that's the GPE. I've been given a height. I need to be careful, it's in kilometres, and they want to know the mass. So I'm going to rearrange this equation so that m equals GPE divided by GH. I want m on its own, so I'm going to move the G and the H over to this side. And personally, I prefer to have the subject on the left, so I've written it this way round. Up here I didn't, but generally I do. So I've got 30,000 joules divided by G, which I know is 10, and then times that by the height. Now the height is 0.2 kilometres. I can't write that because that's not in metres. 0.2 kilometres is 200 metres. Now the reason I know that is because I'm going to use a conversion. So kilometres, I multiply by 1,000 to get into metres, and 0.2 times 1,000 is 200. The mass of the dog then comes out as 15 kilograms. And if I just think, is that a common sense kind of check? Yeah, that seems pretty all right. Like, it's not surprising for me to have a dog at that mass. So that's GPE, or the basics of GPE. We're going to move on to kinetic energy. Okay, this is another form of energy, and it's one that you need to know the equation for again. Now, kinetic energy is the energy that an object has because it is moving, and its equation is a little bit more complicated than the one for GPE. Kinetic energy is equal to 1/2 mv squared. Now, the KE is the kinetic energy, and that has got the unit joules because it's an energy. Half doesn't have a unit, it's just a number. M stands for mass, once again with the unit kilograms. We have to make sure the unit's in that. And then V stands for velocity or speed. Now this must be in meters per second. So if you've got your answer, your question in kilometers per hour, etc., which we'll look at later on, you've got to change it to meters per second. Be really wary of the squared and the half. People like to forget both of these when they're using the equation. Now, the most common thing that happens with this equation is to ask you to rearrange it in terms of the speed. So they give you the kinetic energy and ask you the speed. So to rearrange this in terms of speed so that V is on its own, there's two ways you can do it. You have to make sure that V is on its own and everything else is moved to the side. Now, the way I generally do it is this way. I think to start with, right, the half is the most problematic. A half is 1 divided by 2. So to get rid of the 2, I'm going to move the 2 up to the other side. So I'm going to write 2 KE equals mv squared. Then the m, and it's multiplying here, so on the other side I'm going to divide by it. So I'm going to write 2 KE divided by m equals v squared. And now I've got a squared and I don't want that, so I need to do the opposite to the side. So I'm going to write the square root of 2 KE divided by m equals v. The other way I can do this is to deal with the half slightly differently. I can say, instead of I'm dividing by 2, I can say I'm multiplying by a half. So to get it to the other side, I need to divide. So I can write KE divided by 1/2 equals mv squared. Bring the m down like over here. So KE divided by 1/2 m equals v squared. And then v would equal the square root of KE over 1/2 m. Both of these equations are equivalent to each other. They're exactly the same. Dividing by a half is the same as multiplying by 2. Now, for both of these questions, you might sometimes see the kinetic energy or the GPE written slightly differently. You might see this written as EK with a little subscript. And for GPE, you might sometimes see this written potentially as EP, where the P stands for potential. So don't be alarmed if you see that instead. Okay, let's have a go at some questions with this slightly more tricky equation. We've got here a 5 kilogram cat runs at 8 meters per second. What kinetic energy does it have? So this is a straightforward sub into the equation, but it's really easy to forget to square or to halve. So K equals half mv squared, which equals 1/2 times the mass, which is 5 kilograms, times the speed, which is 8 meters per second, squared. So when I put that into the calculator, I'm going to start by writing 8 squared, which comes out as 64, times by 5, times by 0.5 or a half, and the answer comes out as 160 joules. Now, if I've got the same cat, that means once again I've got the same mass, How fast must that cat run to have 360 joules of KE? This is a classic example of wanting to use this rearrangement. How fast means work out the speed. So normally in an exam, I would go through this then. I'm not going to now because I did it before, and I'm going to go for my usual version, this one here, and I'm going to write the equation down as V equals 2 times KE divided by M, all square rooted. So the speed equals 2 times the kinetic energy, 2 times 360, divided by the mass, which is from the first part of the question 5, all square rooted, and the velocity there would come out as 12 metres per second, which with common sense seems not terrible. It's pretty fast, but cats are pretty fast. As a good kind of guide there, Usain Bolt, when he runs the 100 metres in record time, he runs at about 10 metres per second, so this cat is running faster than Usain Bolt, but there we are. They are faster than humans generally. Okay, last one. Seems straightforward. What is the KE, so we're not going to have to rearrange, of a half-ton car travelling at 30 kilometres per hour? Now, before I start this question, I will write down the equation KE equals 1/2 mv squared. But I've got alarm bells ringing because I haven't got anything in the right unit. I've got a half-ton car. Now, a tonne is 1,000 kilograms. So a half-ton car would be 500 kilograms for the mass. And then the speed, I've got 30 kilometers per hour and I need it in meters per second. So to work that out, what I do is I think about, right, 30 kilometers is 30 times 1,000 meters. So it'll be 30,000 meters. And per hour in seconds, an hour in seconds is 60 times 60 because there's 60 seconds in a minute and 60 minutes in an hour. So if I do this conversion, 30,000 divided by 3,600 as it comes out, I find that my speed is 8.3 reoccurring meters per second. Now, I won't usually write it like this in physics, but we're going to use that later on in the equation, so I don't mind writing it with a dot there. So I can now put my numbers in. So KE equals 1/2 times 500 times 8.3 squared. And I'd usually keep that on the calculator and just square it straight away instead of having to type it back in. And that comes out as this answer, KE equals 17361.1 reoccurring joules. I would never write an answer like this in physics. Firstly, I don't write reoccurrings, I round. And secondly, this is far too many significant figures. As a general rule, you should keep your answers to about 3 significant figures in physics. So 3 significant figures is 1, 2, 3 up to this point. So I'd actually write this as 174, because it's going to round up from that 600 joules. So that's the basic use of kinetic energy and gravitational potential energy equations. You will sometimes get asked to just use them like that, but very often you get asked to think about how GPE and KE can transfer between each other. And there's some really